Hello, everyone. It's Dr. Barden here. I'm starting up this quick recording, or hopefully pretty quick. We're going to go over a lot of the stuff that we'll talk about on Wednesday this week in class. So this is, again, just a recording so that way you can refer back to it and, just have all this information for you there. We're going to be going through a lot of that section, was it chapter 1, the practice section of the textbook. Roundabouts page, 75-ish is kind of where we're starting. So let's just kind of hop into it. The first thing I'm going to do is get rid of OBS, and let's just make this big. So there we are. So first things first, I've got something that we kind of worked with a little bit last time. We've got the cycle object, does a sine wave. The easy DAC, it's just a toggle for the audio outputs. One thing I am going to add, though, is a new gain object, gain tilde, just so we can more easily control the volume of what's happening here. So I'm going to stick that right there. Boom, boom. So now if we lock this, turn on the audio processing. Let me turn the audio a little bit on my mixer, and then about there. We don't need it too loud, but let's turn that off because that'll be annoying. So as a quick review, we had the gain object to be able to control some of the volume here, and we also used a slider object here in order to be able to control the frequency. And you can fine-tune that by selecting the object, hopping over to the inspector window, and you can adjust the range. So maybe I want this to have a range of, if you double-click it, 1500 on the slider, right there. And now if we turn it on, lock the patch, turn it on. We'll leave it right there, but I'll turn it off. All right. The other thing we did is you can resize how these objects look and take up space in the patcher window if that's something super handy for you. Definitely recommend exploring that. Pretty much any object can be edited that way. So what I'm going to show you real quick in this video is a few handy things. The first one is that in this class, and probably in general, you're going to have probably a lot of max patches open at a given time. And to illustrate that, I'm going to just make a new patcher over here. And I'm going to, real quickly, just to make my point, we'll make another easy DAC right there. And one thing that's kind of interesting with Max, and I want to see both my windows here, is that kind of by default with this easy DAC, if you're turning on and off audio, it's going to apply to all of your patcher windows. So if I click this, you can see that it turned on in this background window. We're hearing the sound. Turn it off there. That can be useful or problematic. So there's some handy things that we can do in order to make that not be the case. Because if you have multiple things open, it's just going to be all kinds of noise and hecticness, and it can be problematic as things get a little more complicated. So one thing you can do is with the easy DAC or just the normal DAC object, the digital to analog converter, if you make a message that says start window, all one word, and connect that to the first inlet, then we get the window here open. If you use that to toggle what's going on, and we're just going to make this tiny because I'm tired of toggling between those. Just tidy that up a little bit. There we are. Now, if we look at these, I've got the two patches here. If we turn one on normally, it turns on the audio for both patches. But if we do start window, it only turns on the audio for this window. You'll notice that the bar here kind of turns orange to indicate that it's a little bit different, but you can turn it off. And if you want to also be handy and do the same kind of thing, you could do a message that just says stop. And now if you were to use these to toggle your audio ins and out, you can start and stop it without affecting other patches. So that's a handy little trick right there to have. And then again, at this point, you don't even really need the easy DAC, although I like the symbol there. You could just do a normal DAC object instead, and it'll accept the same windows. So that's a way, as you start having multiple patches in the class, to avoid them fighting each other when you want to turn something on versus not. So that's the first part right there. We're going to be kind of using that to start with. So one thing that might be handy for you is if you highlight all of this, right click, you can save it as a snippet. Boom. And you can name it as whatever you want, but that way if you hop over here to your snippets, you can find it and have a lot of stuff saved. With the DAC control, here it is, and we can boom, drag and drop it, and it will just be right there. So again, handy little trick. I mentioned that in class last time. So the rest of this shorter little video, I'm going to have a few kind of per topic that we're going to talk about on Monday, is going to be about the scope and the selector objects. These will be something that's going to be really handy as we start putting things together. So let's make a new scope tilde, because we're going to be visualizing an audio signal. As you can kind of see, it has it right there. And you select that, it turns into this grid shape. And what this will do is this will display the waveform of whatever audio signal you're sending into it. So let's make it big, because it's going to be the main focus of today. And I'm going to take the audio signal before we adjust the volume right into there. And we're going to start it. So you see right there, we've got the waveform that's happening. Let's what is our frequency at? 400. So let's take this down a bit. About 155. So you see that that's changed. That might be a little big to work with. So let's play around a little bit. One thing that we can do is, instead of connecting it here, we can connect it after the gain. And sometimes we might have to stop and start the audio, or why aren't we seeing it? Oh, it's because I connected it to the wrong outlet. So one thing, I'm going to get that out of the way. With the gain object, if I zoom in a bit and scroll over, you'll notice that it has two outlets. This one over here just outputs the value of the slider. It's not actually passing the audio. So you want to, whenever you have the audio, you want to stick it to this signal output as opposed to the slider value. So I'll stick it over there, and now if we lock the patch, there we go. So with this, let me zoom back out a little bit. If we can kind of see that in a little bit more of a manageable size. So again, that is the audio waveform that we are hearing. Again, I'm going to stop that there. So this is really, really handy for visualizing what's going on and being able to kind of see the sound. There's a lot of settings that we can play around with if you want. If you right-click it, I just open the help patch. So here's all the reference info as well, the different attributes and arguments, things you can set it there. But again, you can display how much of the buffer, like how much you can see here. the number of samples it'll display. Again, there's ranges and defaults. Excuse me. I'm not going to play around with these right now, but I'm just pointing out that they are there. So if we wanted to turn that on here, you can see the various things and see how it changes as you explore it. Again, some automatic deset settings and values, offsets. You can. I'll let you explore this on your own. For what we're going to be doing right now, this will be just fine with the default settings. Again, it is scope tilde it's like an oscilloscope. It will display the audio waveform that you are looking at. So I've got that there. I'm going to start by making some new sounds, essentially. Then we're going to be able to see them in the oscilloscope here in this little video. So let's start playing around with that. So far we've only played with one cycle object at a time. So let's play with multiple. So if you hold down the Alt key on Mac or Option on Alt on Windows, Option on Mac, and then click and drag, it will copy whatever you're clicking and dragging. Right there. So let's take that. And again, this cycle object, by default, when you open it up, it's going to output 500 hertz. But then you can change that with the fader. So this one's going to, over here on the right, is always going to be 500 hertz. This one over here can change. So let's just stick this into the gain object as well. We'll lock that up and we'll start it. It's close. 21. I'm trying to get it to line up as really close. That's pretty close there. I'm going to stop it for the sake of time. But as you start combining different sounds, you get unique outputs here. That's going to be what we focus on a lot on Monday, is the idea of additive synthesis. And the idea that we can combine sounds together to create unique timbres and pitches and things of that nature. So what we're going to kind of be exploring is the different waveforms and envelopes to apply to those waveforms is kind of my goal for today. And again, I'm going to split this longer video up into some shorter ones to put in the Canvas page for you. So right now, what we have going on is these two sine waves here, one at 498 hertz, the other at 500. They're both getting essentially added together and output, and we can see that happening here. We have some beat phenomenon where the waves are kind of canceling each other out as they kind of line up in different ways, and we can see that here in the oscilloscope. We may talk more about beats later. Just know that when things are almost in tune, you kind of get this effect to happen. But again, that'll be more in some of the amplitude modulation and things like that is when that'll come into play. So what I'm gonna pull up now is, instead of this, we're gonna add a few new things. So I'm gonna just move these up here, and I'm going to disconnect them from the gain, and I'm going to start by I'm on a Windows here, holding down Alt. Again, that's Option on Mac, and I'm going to I think we just need 4 of them here, have a few options with that. So instead of cycle tilde, I'm going to pull up try tilde. I'm also going to pull up saw tilde and rect tilde right there. So these are all objects that output different waveforms. If you recall from the very first class, I played a little bit of each of them, and we're going to hear them again in this video. Basically, it's different patterns of how the computer is going from that high to low value, if you want to look at it purely practically. But these are essentially the kind of basic building blocks that a lot of synthesis comes from, and you can use this to create different timbres and play with different sounds. So I have this set up so that way they're all connected to this single slider, so we could hear the same pitch but different, the different characteristics of each waveform. What I'm going to add next is a new Selector tilde object. So if you look over there, it assigns one of several inputs to a single outlet. So I have that there, and by default, it just has two, 1, 2, and you can tell it which one to send. That's handy, but we have more than two things there, so I'm going to hop at the very end of the name and hit space, and then you see there the arguments. We have the number of inputs. Well, we want 4, and you can actually specify which one is initially open if you want. So let's say input 1 is initially open. We click that there, and you'll notice, let me zoom in, that there's a lot more inlets at the top now. So the very first one, this tells us which inlet we're selecting. So I'm going to connect, there's 1, 2, 3, and 4. And then if we just go out the bottom into the gain object, we will now, by default, of these 4 inlets, number 1 will be selected. So if we start the audio, we should just hear a basic sine wave. Sine wave, all right. A single sine wave. That's all at 498. That's close enough. You can see that there. We'll look into that a little bit more later, but single sine wave. So now I'm going to make 4 message boxes. Unlock the patch. 1, 2, 1, 2. I always do that. 3, 4. All right, and these are just going to double click to simply say 1, 2, 3, 4. And we're going to connect all of these into that very first inlet. So the very first inlet of the selector object will tell us what of the remaining inlets are we going to use. So I'm just going to make this slightly easier to read. Right there. And if we lock this patch, now we can toggle between each of these 4 inlets. And I made sure to move the slider so that way the value is here on each of these message cables. Before I do that, as a side note, if you notice me hovering the mouse over something to see what's going on, those are available up here in the debug menu. The event and signal probes, I don't use the matrix one pretty much ever, but what it'll do is when those are clicked on, if you hover your mouse over a message line for the event probe, you can see what, if anything, is being sent. And when audio is running, if you hover over a audio signal, you can see basically like the scope, the specific value that's being sent at that time, and then a graphic representation. So it's super handy. So again, by default, we've got number 1. I click on that, nothing's happening, but I click on number 2, and the sound changes. Now we've got this triangle wave. 3. happening right there. And I didn't have the scope in frame there, so let me just do that really quickly so you can see the differences in the signs. So we'll start on the sine wave. So again, each of these waveforms have a different visual look to them, and they have their own unique characteristics. I'll let you kind of decide how you want to categorize each of them in your mind. I like to think of it how they look visually. So with a sine wave, that tends to be a more very gradual change from high to low. Triangle, it's a linear up and down. The sawtooth is kind of in between the triangle and rectangle, so it's kind of gradual and then sudden. And then the rectangle tends to just be up and down. Because of the way these particular objects are synthesized, you notice it's not perfect. There's a little bit of little aliasing happening on there. The textbook goes into some more info on that kind of thing. You can explore that on your own. I'm not going to dive into it in this video. Okay, so at that point we've got the selector object, and we can explore a few different ways to play around with that. I do want to point out one thing that'll make your life probably a little easier, and that is if we make a new object called a U menu. It's a pop-up menu. And we'll stick that there, and I'm just going to make a single message box that says append 1, append 2, and I'll hover over this there, append. It just adds a menu item to the U menu. As you can see right here, it's a U menu method, add a menu item. Append space 3, append 4. Okay, and what I'm doing here is just I'll connect this to the U menu, lock it, send the message, and now we don't need this anymore. But now this little drop-down menu, it will send a message, but we can just select it from a single object. So instead of having these multiple objects here, you could instead unlock the patch, connect just a single one into the selector, delete that, and now it will send whatever message we want here just from a single drop down. So if we start the window, for some reason it didn't like the sine wave. Oh, that's because I goofed. It's sending the, I clicked the wrong one. The outlets here. This one will send the item number, so it'll start at, if you've done a lot of computers, a lot of things are what we call 0 indexed, which means it just starts at, this is menu item 0, menu item 1, 2. It's like something's not lining up. If to send the actual content, we actually want to connect it to the middle one, if I remember right. Yep, menu the text as a message. So yeah, a lot of times it's the first inlet and outlet that you use by default. Some objects are slightly different. So if we connect it to the middle outlet, now things will actually work as expected. So sine wave, there we are. Sawtooth, square, triangle with a little bit of wobbliness happening. So there we go. I had that almost set up right there. So again, that's just ways that we can explore different basic ways. We're going to look at how we can kind of combine them in some additive methods a little bit later. But I do want to explore one other thing today, and that is the idea of an envelope for a sound. So I'm going to kind of walk through and talk about a specific patch that is done in the textbook and kind of break it up as to what is happening in the patch and talk about what an envelope is, why that might be useful, and go from there. So with that being said, let's just add it into this patch as we're going. So we don't need this append message anymore. We can just get rid of that. But what we will need is, well, a handful of things. So let's dive into the list. So we've got our tones right here. We're going to keep that. And what we're going to add are the... Where'd my list go? We'll start here. We'll start with a line tilde object. So line tilde. And this is going to, again, it's got that tilde after it. It's going to basically generate a specific ramped output. It's a line, a linear, from A to B. And basically what we can do is use the output of this object and combine it with the outputs of the synthesizer objects to make it actually sound like a note. You may have noticed so far that it's just... I always forget to lock the patch. It's just the note is on... Make it a little louder. Or the note is off. Like there's no notes happening, nothing really musical there. That's just how the computer works. Again, it's all digital, ones and zeros, on and off, yes and no. There's by default no real way to make it be a note that you would play, and that's where the idea of an envelope will come in. So an envelope, if you're not familiar, is essentially, I like to think of it as like a physical envelope. If you've ever mailed something or received mail, it's usually in a box or a little envelope, and the sender has to physically fit whatever they're sending inside of the constraints of that box or envelope, and you're making it fit that shape in a lot of cases, and that's what we're doing to this sound, is we're going to make this constant stream fit into the shape of a note. And the envelopes have a very specific set of components, that being the attack, decay, sustain, and release. So what I will do, I didn't have this prepped, is pull up an image here that is very common. You may have seen it before, but we're just going to have a new window. ADSR. So let's I just want to see the image. There we are. So the attack, decay, sustain, and release. So these four elements essentially make up, on a physical what's happening level, all of the notes that you're going to hear. And by adjusting these different values, you can shape the notes into being whatever you want. It could be a super short percussive hit or a very long sweeping pad kind of sound. So the way that this works is that you have the attack, and that is essentially a ramp up to a very high value, followed by a decay where the volume kind of fades down just a little bit. I like to think of it as the note needing that little bit of extra energy to start from nothing and start the vibrations to hear it. It needs that extra oomph to get started. So then after that oomph, that initial peak, it's going to be sustained at whatever volume you need it to be sustained at for however long you're going to have it there. So sustain at that volume, and then it's going to release and fade back to zero. So if you're playing on a keyboard, when you press the key, you press it with that initial force to start the note. You're holding it out for however long, and then when you release, does the note, fade to nothing immediately? Does it have a very long tail? Playing around with those values will change how the note works and how we hear it. So that's what we're going to be doing with the line object here. All right, so let's get this all connected, and I'll talk about what they're doing as we are connecting it. So, line tilde. So the first thing we're going to do is to give it the envelope that we want to generate, and to do that, we need a message. So I'm going to unlock the patch, make a new message, and we're going to start at 0, at no sound at the very beginning. So 0, comma, and then I'm going to start with the example they have in the book, but we can explore other options. So we can say 2,000 over 2,000 milliseconds. We're going to go up to the value of 0.8. And then I'm going to hold for 1 second, so 1,000 on that sustained time. And then we're going to go to a value of 0 over 100. So I've got these numbers right here, and we can open up this. I think they do it the same way. Yep. Oh, that's over beats. I don't want beats. List input. Here's the list inputs that we're playing with here. So a list will set a new target value and a new target time. You can put up to 100 value time pairs in a single list. So we basically just start at 0 and start sticking those there. So we're gonna boom. This represents our envelope. Again, I'm kind of summarizing some of the stuff that's in the textbook here, so definitely refer back to that. But we can use this to trigger the note with this particular property, and we'll make a few of these and explore how they sound a little bit different from each other. So from there, what we have to do is just combine this with this. Basically, shove the constant stream of numbers into this shape that we've generated but haven't actually heard yet. So the way that we do that is with an object. It's the asterisk tilde. There we are, and sometimes it gets a little laggy because there's a lot of things with the asterisk, but this is where we multiply two signals together. And we'll talk about that more again when we get to amplitude modulation and additive synthesis. So instead of just combining all of these into a single stream, you are taking the value of this side and multiplying it by the value of this side over here. So if we just connect A and B, I mean, that would still work, but A and B, there we are. So when this is at 0, that's zeroing out everything over here. As the line ramps up to these values over time, it will, affect the volume, essentially, of what's happening here. So we can then just connect this right to that, and effectively, we're good to go. If we start the audio, let's put it on a sine wave. You see we get nothing here, but if we click this, I broke it somehow. Oh. I forgot a 1. I'm going to hop back into the message board, add a 1 at the beginning. So now this is making more sense. So, forgetting that 1, I was like, this seems weird, but we're just going to go with it. But we're going to start at 0. We're going to go to 1 over a value of 2,000 milliseconds, to 0.8 over a value of 1,000 seconds, and to 0 over a value of 100 milliseconds. Now that I have fixed that, that's more what I was expecting. Every time I click this, You see, again, we've got that 1 being the maximum here. We've got that 2-second fade in, 1-second fade out, essentially. And we can trigger this note anytime we want just by clicking that message. We can change the waveform, and it's still the same. Same note, different timbre there. And if we wanted to visualize what we have happening there, we could make another scope object. I always forget to unlock the patch. Scope. And we can see here, if we connect that to from the line object, this will show us the that value of the line. And then if we wanted to see the combined audio, we've got that already. Maybe we can make it a little bit bigger if I connect it directly to there. Let's look. So now if we start. Let's see if I can make this just a little bit bigger. Inspect buffer size. Let's make this 256. That did not help at all. This is what I get for not planning this specific part out here. Set the number of samples per pixel to display. If I make this 512, maybe? I'll put this buffer, actually put the buffer back at 128. Well, we'll explore that more later. I wanted to try to get the whole envelope on the screen, but you can still see it progressing there. I'll play with the settings outside of the video, so that way when you get this max patch, it'll all be there. So this envelope here is how we can shape the constant stream of audio that's happening. If you wanted to see compare the before and after, we could make another scope, and I'm going to make this one tiny again, and just directly from the selector, you can see that it's just a constant stream of audio data, but when we combine it with that, we actually get a note that you could use in a artistic context. And we could display a bang. We don't need the bang. Put ramp. We could display it, I guess, with a number tilde. There. So what that number tilde does is it takes the value that we're seeing here, and it's just displaying it as a number. So again, to kind of summarize this, in computer audio, when we're synthesizing sound, the computer is just going all the time. It's either on or it's off. It's on, it's off, off, on, off. That's what it is. That can be useful, especially again if you're wanting drones and everything, but we start to get these clicks and pops and things as you start to play around. Every time you start the audio, it may not be starting right at 0 there, so the speaker has to kind of jump to get to the right spot. You don't always want that. That can, outside of long term, cause damage to your speakers. It can just be not pleasant to listen to, especially again if you've heard these clicks and pops throughout. What's happening there? So by using the line object with the with these specific parameters, we can shape it into a note that you might hear on an instrument. So what I'm going to do is make a few copies of this and connect them all to the line object and change it. So maybe instead of ramping in, I want this to be maybe 1,000 to there. Maybe I want a slightly softer at 0.5, and I want it to be a longer fade out at 500, and then we'll make this one 100 on all of them. So these are, by changing the values, we're going to get different options. So let's put that there. Let's go to the sine wave just for fun. Start the audio. All right, see that there? So here's the first one again. The second one is going to be different now. You notice much more gradual up and down. And then the last one. So again, you can combine these in different ways. So I'm going to put a little comment here so we know what's happening. Comment. So 0, comma. You're always going to start at 0 to start with, but then we want then a 1 next to be, we're going to the maximum. The attack time. And then we want how much the decay amount to be, how long that takes, and then once it's done, this decay time is also, you can think of it also as the maybe the sustain amount, actually. Note length might be helpful. And then release time there. So you can, if you follow this kind of format for your messages, you can set up the notes to be as long or as short as you need them to be. Final thing I'll stick here is I'm going to, using the B button shortcut, create 3 buttons here, because this is fun. You can see exactly what's going on, but this may not be the best in like a performance context for actually, being useful. So maybe you have your notes here that you want to trigger. We can, just make it be a single button. You could attach them to a keyboard input if you wanted to, or a MIDI controller. It's totally up to you. So I'm going to play around. So let's make these be slightly different colors. I'll make that one yellow. We'll make this one blue. I like that blue. And we'll make this one can be purplish pink. So now, whenever we click these, we'll click the button instead. And we just get some nice visual elements to that. So what we could do, if you wanted to make this nice and pretty and easy to interact with, I'm going to select this scope, right-click, add to presentation, or the command or Control-Shift-P, a command on Mac, Control on Windows. And if I select these, add those, we'll add this, and we'll add that. So now if we hop over into presentation mode, we can see, here's this option. So we want to be able to adjust the volume, frequency. We can see what's going on here. And then our notes, our buttons, let's make the buttons a bit bigger. And we'll put them, here, and we'll move this one here instead. So now we've got a much more condensed user interface happening on the screen. Everything else is still there. You can see it there by toggling back to patching mode, but now we can much more easily lock the patch and we can interact with it and see what's going on in a much more intuitive manner. So that's kind of the last thing I'm going to be showing today in this video. And again, I'm going to break this into some smaller sections so that way you don't have to listen to a whole however long this video is recording. If you just want a quick review over, okay, what does Selector do, or what on earth do these numbers mean here? So again, the idea to kind of summarize everything up, one final, quick review is that we have these 4 objects right here that create different waveforms. When the computer is running, it is just constant. They're constantly generating those values. There is no, it's just on or off. That's it. Those are the only options. We can set an initial frequency by after you type in the name of the object, hit space, and then the amount of hertz that you want it to start with. But you can change them by, with the first inlet, just sending in a number. Real handy to do with a slider right there. The selector object is very handy for having multiple audio sources and then just picking one at a time. So you can send that with a message that just tells you which, inlet you want, or you can again use that U menu object to select a specific one. Just know that if you want it to be the whatever's appearing here in the object, it's in the middle outlet. With the selector, you just have to tell it how many inlets there are, and if you want any of them to specifically be like the default one that's on. Again, you can adjust volume with the gain tilde object. The start window message will start and run audio, but only in this one patcher window. So if you have multiple patchers open, that's a handy way to make sure that you don't just all of a sudden have a cacophony of sound and you can't find where it's going. The scope object will let you visually see what's happening in the sound. Very useful tool to have. At the very least, it lets you know when sound is happening. What we have going on here is creating an envelope, so that way it sounds like a note that you would want to actually play with a virtual instrument. And what we're doing is just taking the value from the constantly generated sound and multiplying it by another value here. And so by default, we're starting at 0. The line object is going to just linearly move starting at 0. It's going to move, in this case, from 1 over 2,000 milliseconds down to 0.8 over 1,000 milliseconds, and then back down to 0 over 100 milliseconds. So by adjusting, you've got the value time pairs here. So by adjusting these, you can make your notes longer or shorter, depending on however you need. Again, using that ADSR idea of, again, we're starting at 0. We're giving it that initial oomph of energy to start. Then we're fading, that goes back down to whatever we're actually sustaining the note at. And then when we're done with the note, we've released the key, essentially, and it goes back down to complete silence. Let's see, and then the number tilde is just displaying that value as a number. And I think that's everything we have right here. So with this patch, you can effectively explore the different timbres at different frequencies and create notes that play along with them, so it's not making weird pops and clicks and things like that. Next class, what we'll do is start combining these in different ways in order to create unique sounds. So you'll be able to not only play a note frequency, you'll be able to make it start sounding how you want with the idea of additive synthesis. That's going to be our next main focus. So that's all I have for you this time. If you have any questions, as always, my office hours are Tuesday, Thursday from noon to 2, or send me an email, and I'd be more than happy to help out however I can. I hope you have a great rest of your day. Bye.